Hi there, this is Jacob Nash, and this is a review of 5.04, where we have confidence intervals for proportions in AP statistics based on 5.04 for the VirtualSC course. And I'm using Wixie in this video again. I know that I said that I might have said this already, but I have not used this website in a while. Like I used it like from 2010 to 2020. I was kind of surprised that it still even existed, but I just bought their subscription, so I guess I'll just start using this because Class Notebook is kind of dumb anyways. And this is what I've been using anyways. All right. Or had been using. All right, so the only thing that I don't really like is that you can't draw over the images, but I guess it's not that bad. Sebastian wants to estimate the proportion that sophomores in his high school like to water ski. He interviews a random sample of 60, right? It's always good to write things down, right? So I'm going to say n equals 60. Of the 150 total on campus, so we can just say that the total amount of sophomores we know is 150. He finds that 19 like the water ski, so we can say x equals 19. And we can also say the proportion is 19 over 60. So is the independent condition for finding confidence intervals met? So what does a confidence interval mean? Well, we don't even have to find that in this question. We will in the next one, or maybe the next one, I don't know, but it's basically telling us that we are something % confident that the proportion of something in the population is between something and something. That might make more sense in a second. You'll notice that it's never a chance. It's never a % chance, okay? But if we even want to do this in the first place, there are some things that have to be met. And you might think that A is true. Yes, it's true that n times p hat equals 19 and n times 1 minus p hat is 41, which are both at least 10. So that does follow that rule, but what we really need to know is the 10% rule. Because the 10% rule is saying that 10 times n must be less than the total population. All right, well, 10 times n, that is not a true thing, right? 600 is not less than 150. So that's the reason why it's not met. That's just a 10% rule. Okay, so here, all right, we have a survey. There's 3,000 randomly selected teenagers. So let's just say n equals 3,000. It's not that easy to write small on this, so let's see. Well, that's not what we want. I don't know if there's any. Ooh. No, there's no, I don't know, just whatever. Okay, so asked if they would cite their primary transportation method to school. 15 of 20 said that they use their car. All right, so there we go. That's our proportion. A 90% confidence interval to estimate the true proportion is found to be that. I'm not going to say those two numbers, but that's basically saying, okay, we are 90% confident that it would be in between those. So let's see. 90% of the time, the procedure will capture the true proportion. Okay, so that's how we know that A is right. All right, let's move on to the other one so I can explain why they would be wrong. All right, B, 90% of all samples in the size Okay. That's not what it would yield a confidence interval. That's just not the way that we say it. We're basically trying to say that we are 90% confident. That's why it's called a confidence interval. So we wouldn't say it that way. C, there's 90% chance. All right, C and E, see how it says chance. Chance for confidence intervals is not ever what it is. So you could already rule out C and E. And then D, 90% of the samples, yeah, that's just kind of like B. That's just not the way that we say it. A good tip is that usually the longer, more descriptive one is the case. Not always, but that's just the way that we say it. So that's just kind of like a wording thing, you know. Sometimes there's dumb things like that, but just how it is. Cilantro tastes like soap to some people. The soap is inherited through an olfactory receptor gene. Yeah, that doesn't matter. All right, about 14% of the population. Here's where we're gonna actually have to do some formulas and stuff. Has the gene, all right? So that's gonna be our P hat. We use P hat in this case. You want to estimate the proportion of Americans. Yeah. All right. So it's saying that there's 3% margin of error. Sometimes people say this as mo. Some people call that mo. And 90% confidence. So, whoa. It's about to make it go away. So, but what we're trying to find is actually N. That's not usually what we have to find, but that is this time what we have to find. Usually what we might have to find is the margin of error or something else like that. But let's see what the formula is for this. Well, so there's two ones. There's one that's for p hat, and then there's one for the mean, but this is for p hat because this is confidence intervals, proportions, not means. And sometimes people will say something kind of weird where it's like a z with a divided by 2 or something like that, but we are just going to say z star. That's what we're going to just say. So it's kind of pointless that there's multiple ways to say this, but that's just how it is. And again, as always, 1 minus p, some people might say q, same thing, because that's what q equals, all right? We're trying to find n, so it just depends on what you want to do. You could solve for n already with the variables as if you're in AP Physics, or you could just plug them in, and that's just what I'll do. I just don't feel like rearranging it right now. So we're going to plug in 0.03 for MEP. Well, I said MOE. We can just say ME. There's not usually a typical symbol for that margin of error, but that's what it is. Okay, Z star, we weren't given that, you might say, but here's what we have to do. So this is something that might seem a little bit confusing, but it's not actually. Okay, so you see how it said 90% confidence. So whenever you see something like that, just draw like a normal curve looking thing and then just make a middle section, whatever it said. In this case, it was 95%. And so then you have to think, what would the two equal sides have? So there's 5% left, so each of these sides will have 2.5% in them. All right. And so what we have to do is know that right here is Z star. And right here is negative Z star. We don't really use that, but. And so we have to think what percent is to this point. So is there a highlighter on here? Maybe that's highlighter. Oh, no, that's definitely not. I don't know. I feel like there used to be a highlighter on this thing. Maybe not anymore. I don't know. This might be more of an art website. I don't even remember. But basically, what is all of this? Because we're saying to that point is Z star. That's what we're trying to find. What is this right here? Well, in total, that is 97.5%. See if you add all that together. So Z star equals 95 point, or no, it doesn't. It doesn't equal that because what we actually have to do, we have to do one more step. So that actually, that's what that is right there. But what we have to plug in right here is not going to be that. We have to do our env norm thing. So here's what we do. It's not hard. So second vars env norm, and then type in. It might be different than this if you have a more modern calculator. You can just do make sure that that standard deviation is 1 and mean is 0. But if it looks like this, then we just do 0.975, because remember, so we always do that first, whatever the Z star turned out to be. Then we do 0, we do 1. Like I said, if you have a more modern one, it might already be set to that. So 1.96 is what we see here, and that's what we got to plug in right here. 1.96. All right, and then now we have to multiply that by P star or P hat 0.14 times 0.86 divided by N. Oh yeah, remember that's what we're finding. And as I always say, the only reason why you might think, oh, that takes so long. Well, no, it's because I'm explaining it. Of course, it takes longer for that. And so I hope that you know how to do algebra, but I guess I'll just do it anyways. But we would divide 1.96 on both sides. And so we get that on that side, and then we have to do 0.04 times, or 0.14 times 0.86, which is 1204, 0.1204. Okay, then we square both sides. We square both sides, and that's going to make us have a very small number, which is, we just have to do scientific notation for now. And that equals, sorry, this is messy. I just don't have a lot of space on this. 1204, 0.1204 over N. Then if we cross multiply, we would figure out that it would be that scientific notation thing times N equals that. You divide by the scientific notation thing on both sides, so it's 0.1204 divided by 2.34 times 10 to the negative 4. And that is about 514. And that's how we get our answer there. So to refresh or whatever recap, you just need to write down what it says. Then if we're trying to find, anytime it says to find the proportion of people that, or how large a sample must be, that means we're finding N. We use this formula. We plug in things, and remember to find Z star, we have to do this thing to figure out. It's basically going to be, here, maybe there's a specific way I can say this. Z star, dang it. Z star is going to be let's see, what are they? The confidence, why does it go off of that? If I go, I might cancel my membership or whatever. Okay, so conf percent, I guess I'll just say, divided by, or not divided by, no, plus 0.5 times, oh my gosh, I did not leave myself enough room. Okay, I'm sorry that this video might seem annoying right now. I'm just trying to find an easier way to say that, so you don't always have to draw that thing. It's going to be the confidence percent. Add that to 1/2 0.5 times 1 minus confidence percent, but it would be as a decimal, obviously, because remember that's what we did. It's 0.5 because it's going to be half of what's left over added to it. So might want to screenshot that, and if that doesn't make sense, then just do it this way. All right. Oh, let's move on. Okay, so faculty members at Lowell Place High School want to determine if they have enough students for Valentine's Day. 88 of 200, so hopefully we just know that's 44%. 88 out of 200. Didn't know, just type in the calculator. So p hat equals 0.44. And it's basically saying construct and interpret the 90% confidence interval. Okay, what do we have to do this time? Well, this time, gotta do something a little bit different. We're not going to use that same margin of error one. We have to use a slightly different formula, which is this. P hat, you know what, let me just do it on the next slide because I'll have more room. P hat equals Z star times, kind of hard to draw. And then our usual thing that we already used on the margin of error formula, which is this. Or not, sorry, I don't know why I said equals plus or minus. That's actually what it is. So yeah, that's the only difference. So it's pretty much the same as the other one, but you just have to do p hat plus or minus. And we still find the things the same way. So all right. Let's just find Z star, okay? So it said 90% confidence interval. All right. So that means we're going to do 0.9 plus 0.5 times this. So, I mean, if you think about it, there's 5% left over on each side. So that's what it would be. Okay. So 0.95 is what Z star is, but remember we have to do the env norm thing. So env norm, here, I'll just type it in the calculator. That's probably better. Env norm 0.9501 0 or so 1.64. So we're going to do, remember our p hat was this. We're adding it or subtracting to this, or it was 1.64. Yeah, what it was. And we're multiplying it by this. I'll just go ahead and do that. All right, and then our sample size, that was 200, remember? And so basically, I hope you know how to type something in the calculator. You would do it one time with the plus, one time with the minus. So when it's the plus, we will say U, and then we'll say L for the when we did minus. When it's the upper one, then we see that it's 0.498. When it's the lower one, 0.382. So we are 90% confident that it's between 0.382 and 0.498. And so that's our answer. And that's what E says. And notice that it is not any of the ones that say chance. So definitely not B. We are 90% confident. We should know that it's either A or E, and obviously it's E because that's what numbers we got. Okay, so then this one we don't have to do any math, but it's just something that we need to know. You collect a random sample of size n and that you calculate a 90% confidence interval. Which of the following strategies has a new confidence interval with decreased margin of error? Whenever we're doing that, we have to use the 95% confidence interval. That's just something you have to remember. If you think about it, like remember we have 3% margin error, 98 minus 3, whatever. But just know that it's got to be 95. So if you remember a number, just remember 95. And there you go. So I know this might seem a little bit confusing, but it's really not that bad. And so I hope this helped.